So now if we go ahead and work out the top, what we're given, or if we keep working on the top, we're going to get x and t is equal to alpha a of p of x and t plus alpha a squared over 2 of p of x at second x derivative t plus 1 times negative a of p of x, so that's going to be a minus actually, so minus a of p of x and t. So then minus alpha times negative a gives you plus alpha a of p x of x and t. Let's rewrite that over here. So that was plus alpha a of p of x and t. And then this term over here is plus alpha squared over 2 of this. And then finally a minus alpha a squared over 2 of p of x and t. Okay, so now given this, we can actually simplify this a little bit. So this term and this term are opposites, and so they're out. And so we're left with this right here is equal to alpha. And we can actually start now grouping terms. And so what we'll have is we have 2 alphas here, right? So this is 2 alpha a of p of x and t. So the first derivative of partial derivative of p. And so what we actually have is 2 alpha minus 1 of p of x and t, right? And we've forgotten an a here. So a of p of x and t plus, and then in this case we're left with only one second derivative, so a squared over 2 of p of x and t. So now I'm going to erase this bottom part to kind of highlight this, because now we've basically got it into its final form. And so as you can see, we've got an advection term here, right? So this is advection. We've got a diffusion term right here. And these constants before them, and actually what we're going to do, and I've clearly forgotten to do this, is to divide by tau. And so our final equation should be something of this form. P of x and t plus a squared over 2 tau of p of x and t. Okay, so now what we're given is that we basically have our velocity term is a over tau, or so our velocity term will be this, and our diffusion term will be this. And so that's basically what a biased random walker is. It combines elements of both diffusion and advection. And so as you can see, there's both the first derivative of a partial derivative of x as well as the second partial derivative of x. And that's about it.